In this video, we'll be discussing the problem largest submatrix whose sum is 0. So basically, we'll be given a matrix, and in that particular matrix, we have to find and print the matrix submatrix which is having sum as 0 and it has largest elements in it. So if you will see, basically we'll be given a n cross m size matrix and we have to find the largest submatrix. So in the whole matrix, we have to find the largest submatrix which is having the sum as 0. So before doing this problem, we need to understand one thing, that how to find subarray with zero sum. Because if we want to find a submatrix with zero sum, here in this problem you can observe that we want to find submatrix with zero sum. Correct. So we want to find what? We want to find submatrix with zero sum. Okay, with zero sum. Now before that, we need to understand, like basically this is 2D. Since we need to find submatrix with zero sum, so this will be a 2D problem. Before solving that, we need to know how to find in 1D array, how to find a subarray with zero sum. Okay, subarray with zero sum. So in this problem, whenever we have to find subarray with zero sum, once we understand this problem, then the submatrix with zero sum problem will become easier for us, because here we'll be using the concept of prefix sum as well as the map. Okay, so firstly what we'll be doing is, in this case, if you will observe, so in this case what we'll be doing first of all is, we'll be having let's say we have a array, let's say 5, then we have got 10, okay, then we have got 2, then we have got something like, let's say -7, then we have got -5, then we have got, let's say 4, and then we have got 8. Okay, suppose we have got this as the array, and what we have as the sum is, let's say sum is there and sum is given to us as like sum is, like we will take the sum, that is the prefix sum. Okay, now what we will do is, we'll also maintain a map. And why we will maintain a map, you will notice this, because like firstly initially the sum will be 5 only, then the sum will be 15. Okay, after that the sum will become nothing but 17, then the sum will be what, then the sum will become 10. Okay, so as I keep on moving, I keep on adding the ith element inside my sum. Now after this, the sum will be what, 10 minus 5, which will be 5. Okay, then the sum will be 9, and then the sum will be how much, then the sum will be 17. Now what can you notice here? The one thing that is noticeable here is that sum is repeating. You can see the sum here was 5, and again later on the sum became 5. So since I kept on adding the elements, still the same sum repeats. Okay, so this basically means that in between the subarray sum that is added, it must have been 0. So you can observe that this subarray basically is having how much sum? This subarray basically is having the sum as 0, because 5 after the first element 5, when we cumulatively add all the elements, that is 10, 2, -7 and -5, then you can see that the subarray is having sum as 0. That is why we see that repeated sum again. So since we saw 5 earlier and now we are seeing 5 again, so this helps us to identify that there is a 1D subarray with 0 sum. Okay, now with the help of which data structure can we identify that whether a sum has been already seen or not? So with the help of map, we can easily identify whether a sum has been already seen or not. Okay, so basically what we can do is, whenever we see a particular sum, we can store it in a map. Okay, and if we see that sum again, so then it basically indicates that the sum is repeating, which tells us that there will be a subarray with 0 sum, because in between the sum must have been 0. That is why that sum, the sum is repeating. That is why 5 is repeating it. Okay, same logic will be applied when it comes to 2D matrix. Okay, when it comes to matrices, then the same logic is applied there as well, because in matrices what happens is, like in matrices also, whenever the sum will repeat, okay, then in such a scenario we can say that we have got subarrays, submatrix with 0 sum. So let us quickly try and see the example. So suppose that if we write the second test case, so the second test case was what? The second test case basically was, let's scroll down and see. So the second test case basically was what? It was like 9. Then what we had was, so firstly we had 9, okay, then we had 7, okay, then we had 16, and after that we had 5. Okay, after this what we have is, we have 1, then we have -6, then we have got -7, and then we have got 3. So then we have 1, 8, and then we have got 7, then 9, and then 7, then -2, then we have got 0, and then we have got 10. So you can observe that this is the array. Let me just cross verify. 9, 7, 16, 5. Then we have got 1, -6, -7, 3. Then we have got 1, 8, 7, 9. Then we have got 7, -2, 0 and 10. Okay. So you can observe that the subarray, that is this particular subarray, this is having the sum as 0, because in this particular subarray, if you will observe, so the sum of the first two element, like sum of -6 and -7 is how much? -13. Okay, then -2 will be -15, and 8 and 7 is what? +15. So overall sum is basically what? Overall sum is basically coming out to be 0. So that this is a sub matrix with 0 sum. Now how can we identify in this particular problem? Like how to identify? So basically what you can do is you can say that we can try to run for all the sub matrices. Okay, so we will have a left pointer and we will have a left variable, okay, and we'll also have a right variable. So left will indicate the current left column that I am at, and right will indicate the current right column that I am at. So suppose my L is here, okay, like initially my L will be here, R will be here. So this will be the leftmost and rightmost column. Okay, then after that what will happen? My left will remain there, then my right will move. Then after that again my right will move. So leftmost column and then right column. Then after that R will move. So this will be the rightmost column. So left will stay there and right will keep on moving. By doing this, I'll be able to explore all the columns, that is 917, 9117. Then I'll be able to explore the next matrix, that is 971 -6. That is this particular submatrix I'll be able to explore. Then once my R reaches further, then I'll be able to explore the submatrix which starts from the first row and ends at the which starts from the first column and ends at the third column, right? So now in this case, if you will see, so one of the circumstances will be when my left is standing where? Suppose that my L is standing here, okay, let's say our left is standing here and right will stand here, okay, because basically you can understand that my left will start from where? Left column will start from 0 and left will be, let's say, less than n, and then I'm going to do what? Then I'm going to do a left plus plus, okay. Then right will start from where? Right, you can start from left, okay. It's just like a nested loop, and then so basically we are trying to generate all possible column pairs, right? So first row, like first column, first column, first ending column, right? Then first column, then second ending column, then first column, third ending column, first column, then fourth ending column, then second column, second ending column, like that, okay. Then right will be running and right will be less than n, then we'll do a right plus plus. Now you can see that suppose this is my current left column and this is my current right column. Now after this what we will do is we will have one array, okay. So suppose I will declare one array, and in that array what I will do is that array will be of that array's length will be equal to the length of the number of rows. So basically I from this left column to the right column, whatever elements are there, I will take their sum, and in the corresponding row I'll store the sum. So basically firstly you will see 7 and -6 are there, okay. I'm just showing one of the instances of the dry run. So you can see that sum will come out to be how much? 25, okay. Then if you see further, so sum of -6 and -7 would be how much? So for the next row, the sum of the elements from the leftmost column till the rightmost column, the sum will come out to be how much? The sum will come out to be nothing but, let's say, -13, okay. Then after that the sum will come out to be how much? Here the sum will come out to be 15. Then after that the sum will come out to be how much for the next row? From leftmost column till the rightmost column, it will come out to be -2. Now one thing that you can observe is, if you look at this array, so if I write this array, okay, so this array is basically what? 25, -13, 15 and 2. So basically it is indicating the sum for each row from the current left column till the right column, okay. The ith index is indicating that from the array, okay. Now if you take the prefix sum of this array, then what happens? So let us say that if you will take the prefix sum, okay, let us say that if you will take the prefix sum here, so what happens if you will have a sum variable? Suppose that you will have a sum variable, so you already know what is your leftmost limit and rightmost limit. Now if you take the prefix sum, so in the sum, firstly you will have 25, okay. So you will store that 25 is occurring at which index inside the map. You will store that 25 is occurring at the 0th index. Then after that you will get what? You will get minus 13. So since you get minus 13, so your sum will become how much? It will become nothing but 12. So you are seeing 12 for the first time, you will update 12 with the index as 1. Then you will see 15. Since you see 15, so what you will do? You will update the data with 27. Okay, sum will become 27 and you are seeing it for the first time. So 27 will be updated with the index as 2. Then after that you will have 25, and 25 will be updated with the index like if you see 25. So when you see 25, so 25 is already there inside the map. So now you can say that since 25 is already there inside the map, so you will check the number of elements. So if you have a normal linear array, then the number of elements is r minus l plus 1. But since we are talking about 2D array, so here the number of elements will be nothing but, let's say, I minus mp of the sum, that is repeating. So I is the current index, that is this particular index that we are at, that is the third index. So minus mp of sum, that is, this will give us 0 because 25 already was occurring at the 0th index, plus 1. So this will be the number of elements. R minus L plus 1, like it is basically like R minus L plus 1 into down minus up plus 1. So that will give us the number of elements. If this number of elements in this sub matrix, if it is greater than the number of elements, the largest sub matrix that we have seen so far, then we will update our left right range as well leftmost column, rightmost column, as well as the upper row and the down column, down row. So that is what we need to update. So you can see here now that basically when this subarray sum repeats, so what does it indicate? That here we are getting the sum as 0. So it indicates that from the index, that is from index mp of sum plus 1, okay, that is from the 1th index, that is from the first row, okay, that is from the first row till the ith row, we are getting the submatrix sum as 0. You can observe this submatrix is there now, because you can see 25 was seen at the 0th index, that then 25 is seen as the third index. So this means that from the 1th index till the third index, from the 1th row till the third row, the subarray is having 0 sum, and we already have our left and right fixed. So you can observe that how is the code running. So you can see that basically what is happening here is we have a if you will see here clearly, so what happens is we have a left loop, okay, that is running for the left column. Then we have a right loop that is running for the right column. After that, we are also taking the sum of each array, okay, sum of each row, okay, sum of elements of each row we are taking from left to right, okay, from left to right. Okay, then after that we are also, after this is over, then we ultimately take the prefix sum also, right? So you can observe that this is overall how much time complexity. If you see, so the first loop will be order of n time complexity, second would be, let's say, order of m, because we are running for the column, second would be order of m as well, the third would be order of n, and the other one would also be order of n. So you can clearly see in this particular example so far that there are 3 nested loops, because these 2 loops, internal loops, that is prefix sum loop, and this firstly when I'm taking the sum of each row from left to right, that loop, and the prefix sum loop in which I'm using the map as well, these 2 are running parallelly. So they are having overall complexity as order of n, and then we have m and m. So 3 nested loops, one inside the other. So the time complexity would be m into n. So this will be m square into n. So you can observe that the time complexity will come out to be how much? It will come out to be cubic in nature, that is m square into n. Okay, now this is the logic for the question. Now let's quickly have a look at the implementation, and let's see how I have implemented this code. Okay, so let me quickly show you the code part here, right? So firstly what I have done here is, if you will observe, so what I've done here is, first of all, like we have got this array, right? So we have got this 2D array, first of all, that is named as A. So firstly I take the number of rows and the number of columns here. You can see I'm taking the number of rows and the number of columns. Once that is done, then I declare a temp array, okay, that is ARR array that I was recommending for taking the sum of all the elements of a particular row from the leftmost column till the rightmost column. And I have declared variable that is f up, f down, f left and f right. Now these variables will help me to basically update the, like this variables will help me to keep a track of the uppermost row, downmost column, leftmost uppermost row, downmost row, leftmost column and the rightmost column. Okay, now after that I also have the sum variable, and I have up down because they will be varying, and initially I've initialized the maximum number of elements as int min. Okay, max L will tell me the number of elements in the current sum matrix that is having zero sum. Okay, now what we are doing is we are running our left from 0, left is less than column, then we initialize our array to 0 because we need to take the sum of all the elements from the current leftmost row, the current leftmost column till the current rightmost column. Okay, so that's why we are initializing our temp array or ARR array to 0. Then after that, what we do is, as I was indicating, for that particular row, for every row from left to right, we will do what? We will iterate and we will find the sum of the elements. Okay, now just like I was doing here, you can see this example. When I was doing it here, whatever is written in ARR, that will be done in temp. Okay, once that is done, then what I need to do is I need to call a function. Let's say I will call the function as sum0, although you could have written it here, but if you will write in terms of functions, then this will create more impact on the interviewer. Now what I will do with the sum0 function is, like in this function I'm passing the array, okay, that is temp array, or you can call it as ARR array also. I'm passing the up and the down. Up will indicate the upmost row, down will indicate the downmost row. Okay, these will indicate, up will indicate the upper row, and the down will indicate the downmost row for a row for a matrix which is having zero sum. Okay, and I'm passing the number of rows as well. Now the boolean value will the function will return a boolean value indicating whether I found a submatrix with zero sum or not. Okay, and if I find that, then I already know my left and right because they are already fixed because of the two loops that I'm running one inside the other. And since I'm passing up and down also with ampersand sign, that is passed by reference, so up and down, that is uppermost row and the downmost column will also get updated here. Okay, then after this, suppose that now in this range, how many elements would be there? So this will be down minus up plus 1 into right minus left plus 1, as I have already told you. Okay, because if in a normal 1D array, the number of elements in the range left to right is basically r minus l plus 1. Okay, so for a matrix it will be down minus up plus 1 into right minus left plus 1. You can check that out. Okay, now after that, if I get a if I get the variable as true, so if I'm getting a 0 subarray matrix and the number of elements in that submatrix is greater than the number of elements that I've seen in any submatrix so far, then I will update my final upper row, final down row, and then I'll update my leftmost column and the rightmost column and the maximum number of elements as well. And at the end of the day, what we need to do is we need to declare a answer variable. Okay, that is basically a 2D matrix in which we need to store all the elements for that particular submatrix which is having the sum as 0. Okay, also we need to notice that suppose if there is no subarray, if there is no submatrix in the given matrix, if there is no submatrix which is having sum as 0, then we will return the empty submatrix. Okay, so for that we can check if up left and up down left right are 0, as well as the first element is not the very first element, that is 0 comma 0 element, if it is not equal to 0, then this means that we have to return empty answer. Otherwise we'll store our submatrix and we'll return that. Okay, now let us quickly check the code for the prefix-sum logic, that is for the map logic which we are using. So what we are doing here is we have a map, okay, which will be storing the sum of the array one by one, okay, along with the index. So initially I mark the sum as 0, okay, and this basically array is what? The ARR green array that I have developed. Okay, for this array I will take the prefix sum, and that you can see that I have taken on the right side, that is basically this particular sum that I have taken. So I will take the sum one by one. Okay, so now what will happen here is basically initially maximum length I will initialize as 0. Okay, then we will keep on taking the prefix sum, that is we will keep on adding sum plus is equal to temp of I, that is firstly the sum was 25, then it became 12, then 27, like that. Okay, so if suppose that what happens if the element itself is 0 and the maximum length is 0, so this means that this particular region, if the element itself becomes 0, so this means that this particular element this particular row itself is having 0 sum. Okay, so in that case what I will do is I will simply update my starting row and the ending row as ith row, and I'll update that there is only one element here. Okay, and otherwise suppose if the sum becomes 0, if from the starting till the ith index if the sum becomes 0, so this means that if from 0th index till the ith index, if from the 0th row till the ith row, if submatrix has sum as 0, then this means that submatrix will have the length as I plus 1. So that is why I'm checking the maximum length with I plus 1. Okay, if this happens, then I'll update the starting row as 0, ending row as I. Okay, and I'll update the maximum length as I plus 1, because for a row which is starting from 0 and ending at the ith index, having sum as 0, the length would be I plus 1. Otherwise, I also need to check the the map logic, that if suppose that the sum that I currently have obtained, if it is already present inside the map, then I will say that I will store the old length and I will check the current length will be what? I minus map of sum, that is I minus prefix sum of sum. So inside the map I will check, and if that length is greater, then I will update it with that length. And if the current length that I have got, if it is greater, right, then in that case what I will do is I'll update the ending I'll update the ending row with I, because the I is the ending row, and the starting row will be what? Starting row will be the map dot get sum plus 1. So what, like if you will see here, so we were getting it in the 0th row. Okay, so since we were getting it in the 0th row, you can see for 25 was with 0, but it started from first row, right? So you can see here it started from first row. That is why we will do prefix sum plus 1. Okay, so map sum plus 1. Otherwise, what we will do here is, if that is otherwise, if that is not the case, if that sum is coming for the first time, then we'll update it with the corresponding index, and at the end of the day we'll return if the maximum sum is if the maximum length is still 0. So this means we did not find any sub matrix with 0 sum, so we'll update false. Otherwise we'll return true, and based on true or false, the data will be updated later on. So you can see that this code will be having cubic time complexity in nature. In case if you have any doubts, you can ask that in the comments. And thank you for watching this video. Keep coding, guys. Thank you.